America's drone leaders in 2025. As the United States forges ahead into the mid-2020s, unmanned aerial systems, UAS, have become a cornerstone of modern innovation, reshaping everything from defense strategy and public safety to critical infrastructure and logistics. Drones, once viewed as hobbyist gadgets or niche military tools, have evolved into essential intelligent machines, driving efficiency, safety, and agility across countless sectors. The U.S., long recognized for its aerospace leadership, now finds itself at the forefront of a rapidly expanding global drone economy. According to market analysts, the American drone industry is projected to exceed $58 billion in annual revenue by 2026, powered by advances in autonomy, AI, edge computing, and sensor integration. These breakthroughs are transforming drones from remote-controlled vehicles into fully autonomous, decision-making machines capable of operating in complex and dynamic environments without human input. But within this booming industry, a few standout companies have differentiated themselves by solving specific problems better than anyone else, either through deep specialization, pioneering technology, or agile responses to real-world demands. This video takes a deep dive into 5 of the most influential drone companies operating in the U.S. in 2025. Skydio, the AI-powered flight autonomy innovator. AeroVironment, a veteran in tactical defense, UAVs. Teledyne FLIR, the king of thermal imaging and sensor payloads. BRINC Drones, a public safety partner built for crisis response. ModalAI, the silent genius behind drone autonomy systems. Each of these companies has carved out a distinct niche, offering products and platforms tailored to unique use cases, ranging from battlefield intelligence to hostage negotiations, industrial inspections to robotic AI navigation. Why these 5? The drone market is crowded, with thousands of players producing platforms for commercial, defense, research, and consumer use. However, Skydio, AeroVironment, Teledyne FLIR, BRINC, and ModalAI are different. What sets them apart is not just product quality, but strategic clarity and mission alignment. Each has a clear technological focus, a defined customer segment, and an ability to iterate quickly in response to changing needs and regulatory pressures. Moreover, in an era where national security concerns have forced the U.S. government to crack down on foreign drone manufacturers, particularly Chinese brands like DJI, these American companies have emerged as trusted alternatives, compliant with federal regulations like NDAA and remote ID, while also prioritizing data sovereignty and cybersecure operations. The era of autonomous, intelligent drones. What truly defines drone innovation in 2025 is autonomy. The new generation of drones doesn't just follow a pre-programmed route. They understand their environment, make decisions in real time, and collaborate with other drones, sensors, or command systems. The rise of edge computing and onboard AI allows modern drones to navigate GPS-denied environments, e.g. indoors or underground, detect and avoid dynamic obstacles like people, animals, or vehicles, analyze sensor data on the fly and trigger alerts, interface directly with digital twins, GIS maps, and cloud dashboards. All 5 companies we'll explore in this article are pioneers in these areas, either building autonomous drones, supplying the brains behind them, or equipping them with next-gen sensors to perceive the world like never before. What to expect in this analysis? We'll explore each company through 5 key lenses: company background, origins, leadership, and evolution; core specialization, what problem the company solves best; key products and technologies, the crown jewels of their portfolio; best use cases, where their tech is deployed and why it matters; strategic outlook for 2025 and beyond, where the company is headed. By the end of this video, you'll understand not only what makes each of these drone companies unique, but also how they represent a microcosm of the broader trends shaping the future of robotics, automation, and national infrastructure. Skydio, autonomous flight redefined. Company background. Founded in 2014 by MIT graduates Adam Bry, Abe Bachrach, and Matt Donahoe, Skydio emerged from the heart of Silicon Valley with one goal: to build drones that could fly themselves better than any human pilot ever could. With backgrounds in computer vision and robotics from the MIT AI Lab and Google X, the founding team believed that autonomy, not manual piloting, would define the next generation of unmanned aerial systems. Skydio released its first major commercial drone, the Skydio R1, in 2018. It was hailed as a technological marvel, a consumer drone that could navigate dense forests, avoid obstacles, and track people in motion with incredible precision. While initially positioned for consumers, Skydio quickly pivoted toward enterprise and government markets, recognizing the demand for autonomous systems in critical infrastructure, defense, and public safety. As of 2025, Skydio is one of the most highly funded and fastest-growing drone startups in the United States. It has contracts with the U.S. Army Department of Homeland Security Public Utilities and major transportation agencies, and is now widely seen as the gold standard in AI-powered flight autonomy. Core specialization: autonomous navigation with AI. Skydio's defining edge is autonomy, specifically the ability for a drone to navigate complex environments without GPS, manual control, or external sensors. Their flight autonomy system, called Skydio Autonomy, fuses multiple onboard cameras with deep learning algorithms to give drones 360-degree obstacle detection and real-time scene understanding. This allows the drone to predict object movement, e.g. vehicles, people, animals, replan its flight path on the fly, avoid dynamic obstacles, even in GPS-denied zones, map and remember large 3D spaces autonomously. The result is a drone that can fly under bridges, through tight corridors, around power lines, inside industrial facilities, or deep into forests, all without crashing, drifting, or losing its way. In an industry where most drones still require skilled human pilots and line-of-sight supervision, Skydio's platform is fully self-directed, opening new doors for autonomous inspection, monitoring, and tactical surveillance. Key products and technologies. Skydio X10, 2024 to present. Skydio's flagship drone for enterprise and defense, the X10 is packed with advanced features: 4K/50MP visual camera and thermal sensors, NVIDIA Jetson Edge AI processor onboard, encrypted communications and NDAA-compliance, IP55 weather rating and 40+ minute flight time, optional tethering system for persistent overwatch. This drone is built for first responders, military reconnaissance, infrastructure inspection, and any environment where GPS may be unreliable or dangerous. Skydio Dock, autonomous drone station. The Skydio Dock allows drones to autonomously take off, land, charge, upload data, and be dispatched remotely, turning Skydio drones into 24/7 automated surveillance or inspection units. Docked drones can be programmed to patrol construction sites, utility corridors, or secure perimeters without human intervention, providing unprecedented autonomy as a service. Skydio Autonomy Enterprise Software. This AI flight engine is the heart of Skydio's system. Using machine learning and SLAM, simultaneous localization and mapping, it enables smart waypoint generation, object tracking, and flight planning, even indoors or in GPS-denied locations. Best use cases in 2025: infrastructure inspection and mapping. Skydio drones are used by transportation departments, energy utilities, and engineering firms for inspecting bridges, overpasses and viaducts, power lines and substations, oil and gas pipelines, wind turbines and solar arrays. Traditionally, these inspections required human climbers, helicopters, or bucket trucks, expensive, dangerous, and time-consuming. Skydio's drones can now fly close to structures, capture ultra-high-res imagery, and generate 3D models using photogrammetry, safely, autonomously, and at a fraction of the cost. Public Safety and Search and Rescue, SAR. Police and fire departments use Skydio drones for real-time overwatch during fires or active shooter events, searching for missing persons in forests or mountainous terrain, assessing hazardous areas after disasters, monitoring large crowds or protests, Unlike traditional drones that need constant piloting, Skydio drones can follow responders through buildings, alleys, or stairwells, capturing footage hands-free and enabling fast, informed decisions during critical incidents. Military and defense reconnaissance. Skydio has become a go-to vendor for military reconnaissance in urban and rugged terrains. Units can deploy the X-10 in GPS-denied environments for route clearing, ISR, intelligence, surveillance, reconnaissance, perimeter patrol, BDA, battle damage assessment. Their NDAA-compliance systems are now used in joint training exercises and special operations scenarios where manual drone piloting is often impractical or unsafe. 2025 Strategic Outlook, Scaling Autonomy Nationwide. In 2025, Skydio is doubling down on scalability. That means not just selling drones, but building a comprehensive ecosystem of autonomous drone fleets, remote operations hubs, data management software, integrations with CAD, GIS, and enterprise asset systems. The goal? Make it possible for a transportation agency in Texas, a utility company in Michigan, and a police department in Oregon to all deploy, monitor, and benefit from fleets of autonomous drones without hiring pilots or building infrastructure from scratch. To that end, Skydio is investing in cloud integrations with platforms like AWS and Esri ARCGIS, training and certification programs for enterprise drone users, partnering with municipalities and private sectors to support drone as first responder models. Additionally, international expansion is on the horizon, with geopolitical tensions limiting the use of Chinese drones worldwide. Skydio is positioning itself as the safe and sovereign alternative for countries seeking NDAA-style compliance. Final word, the autonomy vanguard. Few companies in the drone space have redefined what it means to fly the way Skydio has. By placing artificial intelligence at the core of flight, the company has turned drones from remote-controlled tools into independent agents capable of thinking, reacting, and exploring. As we move into an era where drones will patrol our infrastructure, respond to our emergencies, and serve as real-time eyes in the sky, Skydio's vision of AI-first flight is likely to become not just influential, but foundational. AeroVironment, tactical drones for the modern battlefield. Company background. Founded in 1971 by aerospace innovator Paul B. McCready, AeroVironment, AVE, began as a pioneer in ultra-efficient aircraft and renewable energy technologies. But it was in the early 2000s that AV made its mark in the unmanned aerial space, developing a range of small tactical drones for the U.S. military. Today, AeroVironment is a publicly traded company, NASDAQ:AVAV, and one of the most important suppliers of Group 1 UAS, unmanned aircraft systems, to the Pentagon. With headquarters in Arlington, Virginia, and R&D centers across the U.S., AeroVironment's core strength lies in lightweight, portable, and combat-tested UAVs that can be carried in a backpack, deployed in minutes, and operated in hostile or remote terrain. These drones provide real-time intelligence, surveillance, and reconnaissance ISR to warfighters, border agents, and special operations units. In recent years, AeroVironment has also expanded into loitering munitions, also known as kamikaze drones, and has been a key player in supplying UAVs for international allies, including supporting Ukrainian defense forces during the Russia-Ukraine conflict. As of 2025, AeroVironment represents the tactical edge of unmanned defense operations. Core specialization, portable tactical ISR systems. AeroVironment specializes in small UAS platforms designed for tactical edge operations, missions where size, speed, and simplicity are mission critical. Their drones are typically hand-launched or catapult-deployed, lightweight and backpack portable, capable of silent surveillance for extended periods, designed for rugged field environments. Unlike larger, centralized drones, e.g. MQ-9 Reaper, AeroVironment systems are designed to put intelligence directly into the hands of the squad on the ground, in real time, with minimal support equipment. This makes AV drones ideal for forward-deployed troops, special operations units, Border Patrol agents, emergency response forces in defense missions. Key products and technologies. RQ-20, Puma 3A, E All-Environment. One of AeroVironment's flagship drones, the Puma 3AE, is hand-launched and highly portable. Equipped with electro-optical and infrared cameras for day, night ISR, capable of up to 2.5 hours of flight time. Designed for coastal, desert, mountain, and urban operations. It's widely used by the U.S. Army, Marine Corps, and allied NATO forces for battlefield surveillance, overwatch, and target tracking. Check mark RQ-11 Raven. AeroVironment's most deployed UAV to date, the Raven has become synonymous with tactical ISR, 4.5-pound drone with wingspan under 5 feet, 90 minutes flight endurance, operated with a simple GCS ground control station, provides real-time video directly to the squad. The Raven has been deployed in tens of thousands of missions globally and remains the gold standard for short-range tactical reconnaissance. Switchblade 300/600, loitering munitions. A newer generation of AV's capabilities, the Switchblade series introduces a hybrid of drone and missile. Switchblade 300, portable, backpack-carried loitering munition for soft targets. Switchblade 600, larger, anti-armor version with longer range and more powerful payload. Features precision strike, low collateral damage, and man-in-the-loop targeting. These systems have been deployed in real combat, most notably in Ukraine, where Switchblades have proven effective in ambushes, ambush prevention, and defensive operations. Best use cases in 2025. Battlefield intelligence for small units. AV's drones provide a crucial eye in the sky for dismounted infantry units. They are used to scout enemy positions, identify IEDs or ambushes, map terrain in real time, provide overwatch during patrols or raids. The ease of deployment and minimal setup make them perfect for fast-moving units operating in difficult conditions, from deserts to urban warfare zones. Border monitoring and homeland security. U.S. Customs and Border Protection and other homeland security agencies use AV drones for monitoring illegal crossings, surveillance in remote border areas, tracking smuggling routes, day-night ISR without costly helicopter support. With long flight endurance and low acoustic signature, drones like the Puma AE allow agents to cover more ground with fewer people, improving both safety and efficiency. SOS emergency response in conflict zones. In disaster-prone or conflict-ridden areas, AV drones support search and rescue operations, damage assessment in bombed or inaccessible zones, monitoring ceasefire lines or evacuation routes. Their ability to deploy without infrastructure makes them critical during communications blackouts, power outages, or when satellite imagery is unavailable. 2025 Strategic Outlook: Defense Tech for a New Era. In 2025, AeroVironment continues to position itself as a core supplier of frontline UAS capabilities for the U.S. and allied militaries. Key focus areas include expanding loitering munition capabilities with more precise and longer-range Switchblade variants, integrating AI and autonomy into traditional ISR drones to allow semi-autonomous target tracking and route planning, enhancing interoperability with NATO and Five Eyes allies for joint force operations, offering modular payload options for signals intelligence, SIGINT, chemical sensing, or battlefield mapping. Additionally, AV is adapting to the growing demand for non-kinetic UAVs in hybrid warfare scenarios, where surveillance, cyber, and electronic warfare capabilities can be just as decisive as kinetic firepower. The company is also working to ensure its platforms remain NDAA-compliant, ITAR-ready, and operational in contested electromagnetic environments, reflecting the evolving demands of multi-domain operations, MDO. Final word: the tactical backbone of U.S. UAS forces. AeroVironment doesn't make flashy consumer drones or buzzworthy urban air taxis. Instead, it quietly delivers the tools warfighters actually rely on: small, smart, rugged, and ready to deploy anywhere on Earth. Its drones have served in every major U.S. conflict of the past 2 decades, and its innovations continue to shape the future of soldier-carried unmanned systems. As conflicts become more asymmetric and intelligence becomes the most valuable asset on the battlefield, companies like AeroVironment will remain indispensable, not just to the Pentagon, but to the entire Allied defense network. Teledyne FLIR, thermal imaging for tactical and industrial insight. Company background. Teledyne FLIR, formerly known as FLIR Systems, has long been synonymous with thermal imaging and infrared sensing. Founded in 1978, FLIR originally developed high-performance infrared cameras for use in energy audits and military surveillance. Over the decades, its capabilities have expanded across a range of industries, from firefighting and industrial inspection to perimeter security and military operations. In 2021, FLIR was acquired by Teledyne Technologies, a $5+ billion multinational specializing in instrumentation, digital imaging, and aerospace electronics. The merger formed one of the most powerful sensor technology companies in the world, Teledyne FLIR. By 2025, Teledyne FLIR is the go-to provider of intelligent thermal and multi-spectral imaging payloads for drones, powering unmanned operations in scenarios where visibility is compromised or safety is paramount. From emergency responders battling wildfires to special operations teams surveilling at night, Teledyne FLIR provides the invisible insight that makes the difference between success and failure. Core specialization: thermal imaging and sensor integration. Unlike drone manufacturers that build airframes and autopilot systems, Teledyne FLIR's primary value lies in its payloads, the high-tech eyes of the drone. Its core technologies include thermal imaging, long-wave and mid-wave infrared, multi-spectral and hyperspectral sensors, optical zoom and low-light visible cameras, radiometric data collection, real-time video analytics and AI integration. What makes Teledyne FLIR unique is its ability to fuse these imaging modes into a single, compact payload. A drone equipped with a FLIR sensor can detect heat signatures, chemical leaks, structural weaknesses, and invisible threats in complete darkness or through smoke, fog, and vegetation. This makes their systems essential for military ISR, intelligence, surveillance, reconnaissance, industrial and utility inspections, search and rescue operations, disaster response and firefighting, critical infrastructure protection. In essence, Teledyne FLIR empowers drones to see what the human eye or even standard cameras cannot. Key products and technologies. FLIR Hadron 640R, a compact dual camera module combining radiometric thermal camera, 640 by 512 resolution, high-resolution visible camera, up to 12 megapixels, onboard IMU for real-time stabilization, designed for small drones like Skydio or custom ModalAI-powered UAS. The Hadron 640R is widely used in drone-based firefighting, law enforcement overwatch, urban search and rescue. It offers thermal accuracy and visibility in one powerful, low SWaP size, weight, and power package. FLIR Boson Plus. The Boson Plus is a compact, uncooled LWIR long-wave infrared sensor core that delivers sub-30 millikelvin thermal sensitivity, frame rates up to 60 Hz, support for radiometric analysis, modular integration into drone gimbals or robotics platforms. Used in military ISR, border security, and wildlife tracking, Boson Plus is a favorite for manufacturers looking to build intelligent drones with enhanced sensory awareness. Skyranger R70 and R80D Skyraider. Though FLIR is best known for sensors, it also manufactures complete drone platforms. The Skyranger series, originally developed by Ariane Labs, acquired by FLIR in 2019, includes R70, tactical quadcopter with thermal and zoom payloads. R80D, larger version with modular payload options, encrypted comms, and MILSTD ruggedization. These drones are widely used in military ISR, border patrol, and special operations due to their reliability in harsh environments and nighttime operations. Best use cases in 2025. Firefighting and disaster response. In 2025, Teledyne FLIR sensors are indispensable tools for fire departments and emergency management agencies. Mounted on drones, FLIR payloads help detect hotspots in wildfires, assess building structural integrity after a blaze, monitor fire spread in real time, guide responders through smoke-filled environments. Unlike visible cameras, thermal sensors can penetrate through smoke and see through darkness, giving command centers a clear view of unfolding disaster zones. Industrial and utility inspections. Teledyne FLIR payloads are widely used in asset monitoring for utilities and manufacturers, including detecting electrical faults in power substations, monitoring overheating components in mechanical systems, identifying gas leaks in pipelines or chemical plants, inspecting solar panel degradation or wind turbine bearings. With radiometric thermal imaging, inspectors can quantify heat data, providing actionable maintenance insights without shutting down operations or risking worker safety. Military surveillance and night reconnaissance. In defense, Teledyne FLIR sensors are deployed for nighttime surveillance in low-visibility areas, border patrols and tactical overwatch, target identification in dense terrain, integration with UGVS, unmanned ground vehicles for joint ISR. Combined with AI analytics, these sensors can detect humans, vehicles, or threats based solely on heat signature, even when camouflaged or hidden. 2025 Strategic Outlook: Intelligence at the Edge. As drone autonomy increases, so too does the demand for onboard sensing and decision-making. Teledyne FLIR is positioning itself to lead the next wave of edge intelligent drones by embedding real-time AI analytics into sensor payloads, e.g. threat recognition, heat signature classification, pattern tracking. Integrating with partner platforms like Skydio, ModalAI, and Teal drones to offer turnkey ISR and inspection solutions. Expanding into defense robotics, including integration with ground robots and manned-unmanned teaming MUMT frameworks. Supporting urban air mobility and drone delivery with situational awareness cameras for collision avoidance and navigation in dense areas. As edge computing replaces cloud dependency for critical missions, FLIR's ability to process and interpret thermal and visual data onboard the drone becomes even more valuable, especially in low connectivity, high-risk environments. Final word: the vision behind the veil. Teledyne FLIR doesn't just make sensors, it makes perception possible in the places where visibility ends. Whether it's guiding a firefighter through smoke, revealing a hidden target at night, or pinpointing a failed fuse in a transformer, FLIR technologies enable drones to be more than flying cameras. They become decision-making machines with multi-sensory intelligence. In 2025, as drones become autonomous, persistent, and more deeply integrated into critical operations, FLIR's mastery of visual intelligence remains foundational, giving pilots, responders, and commanders the confidence to act with clarity, even in chaos. BRINC drones, crisis response from inside the building. Company background. BRINC Drones was founded in 2020 by Blake Resnick, a young entrepreneur inspired by the shortcomings of law enforcement response during the 2017 Las Vegas mass shooting. After learning that officers had to manually clear a large building floor by floor without knowing what threats were inside, he set out to build a drone that could enter structures, transmit real-time intelligence, and preserve human life in crisis situations. With deep support from police departments across the U.S., BRINC quickly gained traction as a purpose-built drone platform tailored not for wide-open skies, but for the tight, unpredictable, and dangerous environments inside buildings: schools, malls, warehouses, homes, and more. By 2025, BRINC Drones is a recognized leader in public safety UAV technology, working closely with hundreds of law enforcement and emergency response agencies in the U.S. and abroad. Its flagship product, The Lemur 2 is now a core tool for SWAT teams, hostage negotiators, and disaster response units. Core specialization: indoor tactical drones for public safety. BRINC's drones are built around a singular mission: de-escalation and life-saving through visibility and communication. Unlike traditional drones used for aerial footage or perimeter security, BRINC drones are designed to fly indoors through hallways, stairwells, and tight spaces, withstand collisions and keep flying thanks to reinforced carbon fiber frames, break through glass to enter buildings, operate in GPS-denied environments, enable two-way communication between responders and people inside, provide night vision and thermal imaging in dark, chaotic conditions. This makes them uniquely suited for situations where officers face danger but lack situational awareness. Hostage crises, active shooter events, barricaded suspects, building fires, and more. Key products and technologies. BRINC Lemur 2. The Lemur 2 is BRINC's flagship drone, purpose-built for tactical indoor missions. LiDAR-based navigation system for obstacle avoidance in dark/GPS-denied environments. Night vision and LED spotlight for visual navigation. Two-way voice communication system, acts as a mobile phone in the air. Glass breaking attachment to breach windows if entry is needed. Payload dropper for delivery of items, for example, phones, medical supplies, flashbangs. 5.5-inch controller with real-time HD video streaming. The Lemur 2 is a mission-critical tool for SWAT and crisis negotiators, allowing responders to see, hear, speak, and de-escalate, all without entering the danger zone. Checkmark BRINC Ball, a rugged, throwable device that transmits 360-degree video and audio to responders outside. It complements the Lemur drone by offering static, persistent interior surveillance once placed inside a structure. Best use cases in 2025. Hostage and barricade situations. When officers arrive at a home or building with a potentially armed suspect inside, the Lemur 2 can enter through a door, window, or broken glass, fly room to room and deliver live video to the command post, initiate conversation with the suspect via the built-in microphone and speaker, deliver supplies, for example, water, phone, to victims or suspects, monitor suspect activity to support negotiations or tactical entry. This allows police to delay or avoid a forced entry, preserving life and enhancing negotiation efforts. SWAT and tactical operations. In high-risk raids or active shooter events, BRINC drones are used for pre-entry intelligence, indoor overwatch, suspect location tracking, confirmation of room clearance. If a suspect is armed or barricaded, using the Lemur drone allows operators to assess risk without exposing personnel. Disaster response and search and rescue. In the aftermath of earthquakes, building collapses, or fires, BRINC drones are flown through compromised structures to search for survivors, in smoke-filled or dark rooms where visibility is zero, to deliver aid or establish contact with trapped individuals. Their robust frame and long flight time, over 30 minutes, make them reliable even in harsh, unstable environments. 2025 Strategic Outlook: Scaling Public Safety Robotics. BRINC is no longer just a startup. It's a growing defense tech company with bold ambitions. In 2025, the company is focused on integrating AI-assisted threat recognition to help drones identify weapons, people, and movement autonomously. Launching drone as a first responder, DFR programs, where drones are dispatched to 911 calls ahead of officers. Enhancing interoperability with dispatch centers, CAD systems, and mobile data terminals, MDTS. Creating new models for fire departments, hazmat teams, and disaster relief organizations. Supporting federal agencies and international law enforcement with export-friendly tactical solutions. BRINC has also been vocal about ethics and privacy, positioning its products as tools for de-escalation, not surveillance. The company does not support facial recognition or aggressive AI surveillance tools, focusing instead on mission-specific human-controlled deployments. Final word, drones that save lives before shots are fired. What makes BRINC drones different is its unwavering focus on real-world, human-first problems. Instead of competing in the race for high-altitude or long-range flight, BRINC focused on the last 100 feet, the most dangerous and least understood zone in any critical incident. By building drones that communicate, navigate, and survive indoors, BRINC has become an essential tool in modern policing and public safety. In a world increasingly concerned with the use of force and officer safety, BRINC's products offer a more humane, more intelligent, and more effective path forward. ModalAI, the brains behind autonomous drone navigation. Company background. ModalAI was founded in 2018 by former Qualcomm engineers who had spent years developing robotics, drone, and AI technologies inside Qualcomm's R&D division. Led by CEO Chad Sweet, the team spun off to form a company with a singular goal: to provide the computing platforms and software needed to make drones truly autonomous. Headquartered in San Diego, California, ModalAI quickly gained prominence as a core enabler for next-gen drone innovation. Rather than building the drone itself, ModalAI focuses on creating the brains, the autopilot modules, AI processors, and perception systems that give drones the ability to see, think, and act independently. By 2025, ModalAI is a key supplier of autonomy solutions for some of the biggest names in the U.S. drone industry, including Skydio, Teledyne FLIR, and Blue UAS partners. The company plays a pivotal role in advancing the U.S. government's goal of building a secure, NDAA-compliant, American-made drone ecosystem. Core specialization, onboard AI, autopilot, and edge computing for drones. ModalAI specializes in developing high-performance, low-power computing platforms that allow drones to navigate autonomously in GPS-denied environments, detect and avoid obstacles in real time, interpret surroundings using visual SLAM, simultaneous localization and mapping, run AI models directly on the drone, edge computing, interface with multiple cameras and sensors for multimodal awareness. Their solutions are modular, lightweight, and secure, making them ideal for both commercial and defense applications, especially where size, weight, and power, SWAP, are critical constraints. Unlike traditional autopilots that rely on GPS and pre-programmed routes, ModalAI enables real-time environmental understanding, a foundational step for fully autonomous operations. Key products and technologies. Voxel 2 Autopilot. ModalAI's flagship product, Voxel 2, is the most advanced autopilot system in the Blue UAS ecosystem. Features include built-on Qualcomm QRB5165 processor, 15 TOPS of AI processing for edge machine learning, real-time obstacle detection and SLAM, support for up to 4 image sensors and 5 flight sensors, encrypted data transmission and NDAA compliance. Voxel 2 is used in drones across sectors, including defense reconnaissance, warehouse automation, infrastructure inspection, security and surveillance. Checkmark Voxel Cam, a compact sensor payload that combines stereo vision sensors, IMU, inertial measurement unit, barometer and magnetometer, visual inertial odometry. VOXLCAM is designed to add perception and localization to drones or ground robots that lack GPS or external infrastructure. It's particularly useful for indoor autonomy, autonomous navigation in warehouses, mines, tunnels, or dense urban zones. Checkmark Voxel SDK plus Mavros integration. ModalAI also provides a full software development kit, SDK, for autonomy developers, supporting PX4-based flight control, MAV link communications, ROS and MAV ROS compatibility, custom neural network deployment for onboard AI tasks. This empowers drone manufacturers and developers to build customized, mission-specific applications on top of VOXL platforms. Best use cases in 2025. Commercial drone autonomy. Many drone manufacturers use modal AI systems to enable fully autonomous mapping or inspection missions, conduct confined space operations, e.g., indoor inspections, asset monitoring in power plants, tunnels, build drones that can adapt to changing conditions without human input. With modal AI, these drones can fly through complex GPS-denied environments like factories, construction zones, urban areas, underground infrastructure, defense robotics and reconnaissance. ModalAI is a key technology partner for U.S. Department of Defense-backed initiatives like Blue UAS, providing autopilot and compute systems for secure, field-deployable drones. Use cases include reconnaissance drones that operate without GPS, swarming drones that collaborate on battlefield tasks, UGVS and UAS integration in multi-domain operations. Its systems are used in tactical edge environments where secure, robust autonomy is essential. Industrial robotics integration. Outside of aerial platforms, modal AI tech is being used in ground robots, autonomous inventory vehicles, and robotic arms for factory automation, warehouse navigation, material handling, remote inspection tasks. By combining 3D perception with robust edge AI, modal AI systems allow ground and air robots to operate side by side safely and efficiently. 2025 Strategic Outlook, from component to ecosystem leader. As of 2025, modal AI is no longer just a component provider. It's becoming a critical node in the autonomous systems ecosystem, collaborating with manufacturers, government agencies, and research labs to define what American-made autonomy looks like. Its future roadmap includes expanding AI support to run larger neural nets for real-time object detection and classification, supporting multi-agent drone swarms with shared situational awareness, integrating 5G and Wi-Fi 6E modules for faster, lower latency communications, advancing GPS-free precision navigation using only visual and inertial cues, contributing to open-source projects like PX4 and ROS2, shaping the future of open robotics. Modal AI is also helping the U.S. counter reliance on foreign drone tech by powering platforms that are NDAA-compliant, secure, and locally manufactured, a national security priority in an era of growing tech rivalries. Final word, powering the future of autonomy. While companies like Skydio or BRINC build the body and mission systems, it's modal AI that builds the brain, quietly driving the intelligence behind some of the most sophisticated drones and robots on the planet. Its impact is both invisible and indispensable. The AI that recognizes obstacles, the autopilot that adjusts mid-flight, the compute module that turns sensor data into insight, all of these are modal AI's fingerprints on the future of autonomy. As drones become more like flying co-workers than flying cameras, companies like Modal AI will remain the invisible backbone of intelligent machines, empowering the robots of tomorrow with the awareness, speed, and safety they need to operate in the real world.